This is Laurence Dickie from
Hi.
Vivid Audio. We had an interview with him before in Antwerp years ago, but you haven't changed anything in the meantime.
A little bit grayer, I believe.
Well, me too. And a little bit more weight,
Oh, yeah,
but
don't.
who cares? We just saw a demo. I'll weave the images in between so you have an idea what he was talking about. Your speaker design in terms of looks didn't change that much.
No.
But I'm curious about what the differences are
Between
the 1 and the 1S.
the S series,
Yeah.
the changes to the... right, it starts... I'll give you a little history. The G1 was the first of the gears.
Yeah.
And then we did the derivative G2, and then we did the G3 and G4. But the G2 and 3, actually, out of for reasons of economy more than anything, we decided to use the same motor, that is to say, the same magnet and the voice coil,
magnet. Yeah.
but with reduced diaphragm size each time.
Yeah.
And so, of course, it means that on the G2 and G3, it's an over-shoved driver. It's like, I use the analogy, it's crude, but I use the analogy of putting a V8 in a Mini or something like that. You know, it's an overpowered driver for a small cone.
So
but
loads of fun.
well, actually, yeah, conventional speaker design wisdom would say you can't have too much of a good thing. But what I discovered, no, really, if you put too powerful a motor on it, you actually end up with less bass.
Seriously?
Yeah, that's the classic. If you've just got a closed box that actually, as you, from the perspective of the camera, if you have the sort of ideal tuning with the ideal magnet, you get this sort of response, so it goes down at the base and it's level at the top. But if you put a bigger magnet on, the mid-range goes up, but the bass actually comes down, and you actually end up with a first-order slope.
Okay.
And if you have too small a magnet, you end up with a bump at resonance. Okay, I digress. The point is that if you combine this overshoved driver with the passive crossover, you actually can end up with a rather desirable performance. And that's what we ended up with the G2. And we actually, in the end, thought it may not have quite the low-frequency extension of the G1, but it has a certain quality, a certain refinement that appears to come from the combination of the overshoved motor, the rather lightweight moving mass, and the particular size of enclosure. Anyway, so, you know, the G1 was, after all, our first of the gears, so inevitably we did learn some tricks. When it came to G1S, then, my first move was to up the shove, the BL factor, of the motor. And we did that by putting on a 100mm coil instead of the 76mm of the old system, and increasing...
In length?
Diameter.
Diameter. Wow, that's
Diameter.
huge.
Yeah, I mean, a 100mm coil it's actually quite typical on professional drivers, but these are speakers that, you know, you expect to handle a kilowatt of power continuously.
Because you were talking about Pro Audio in your demo. You said that there are certain things that they do very well.
Well, and one of those things is high efficiency and power handling. So, so I've learnt a few tricks from that side of the fence, and I've brought them back into ours. But anyway, so with G1S, bigger voice core, which gives us bigger power handling, of course, as well, and a greater amount of magnetic material, but also I gave it a longer throw. So now the gap length is 45mm. So it means that we have a considerable linear travel. We've always used short coils in long gaps, or underhung voice coils, as some people call them, because the flux is more linear with position. Now, this new driver with the bigger magnet was deeper, and the depth of the drivers, of course, dictates the width of the cabinet. And so it was clear we were going to have a wider cabinet.
Yeah.
And while we were at it, it was an opportunity to approach the industrial design again of the G1, and in fact to take a leaf out of the G2 book. And if you look at the design, you can see that there's much more commonality between the G1S and the G2 than there is between it and the G1. And I think it's a better proportioned loudspeaker from a purely aesthetic point of view. But it did also give us the opportunity to do a better job of the exponential absorber and things like that. It's also, now this isn't particular to the design, but it's more stiffly built but lighter. That's again, as time has gone on, we have learnt how to make composite, dual skin composite materials more efficiently, using less resin and therefore less mass, but with the same stiffness. So, better all round.
Yeah, but did you learn that from the Giya range? Because that's told me it's double layered.
Right. No, so Giya uses a different type of core. Giya at the beginning always used end grain balsa. It was a historical thing, really, but balsa was available in ready cut into small rectangles, whereas the foam cores tend to just be in a big sheet. So there was a certain amount of ease of use, but also we figured that the end grain balsa had a slightly better damping characteristic. I'm not actually sure in the long run whether or not that was significant. And indeed, the world supply of balsa wood has dwindled, or at least the price has shot through the roof, because suddenly everybody's building wind turbines, apparently, and they're consuming vast amounts of balsa wood. Purely pragmatically, we've decided to have a go using the polymer foams, and indeed, they work very well, are even slightly lower in density. So, it's circumstances has brought us here, but we're very happy with the result. But anyway, I digress slightly. The point about, so Giya is quite a laborious process, because we literally cut little squares of balsa wood, and then the guys cut little triangles to fit in the gaps, because you can imagine when you've got these squares going around the complex curve of the surface of Giya, inevitably there are little triangular gaps between them, so they cut by hand these little triangles to fit. So it's terribly laborious, but the result is a very low density product. Low density but high stiffness, with the net result, the structural modes are high in frequency.
Light.
It is. Actually, interestingly, the G1S shell is now about the same weight as the original G2 shell. We've really and the nice thing about that is that the principal reason it's lighter is that we use less resin, and frankly, in this world of dwindling resources and all the rest of it, using less fossil fuel derived resin is a good thing.
Yes, definitely.
So that's when it came to Giya, we were trying to make a more accessible product, and accessible also means slightly less cost. And Giya uses this material called soric, which it's a polymer. It's actually sort of polymer skinned material with lots of little beads, lots of little polypropylene beads trapped in a sort of a hexagonal mesh. The important thing about it is it drapes. You can actually form it to the inside of a curve much more easily than these balsa wood or foam cores. And the net result is that it's a lot quicker to make a Giya than a Giya.
How do you come up with all this stuff? I mean, do you just try it, or do you have a plan?
Well, okay, so the original Oval series was a cast polymer concrete. That is to say, it's a powdered stone, marble actually, powdered marble mixed with an ordinary polyester resin, mix, pour. So twin skin molds. And it's fine. It's actually quite dense. It's reasonably stiff, and it's reasonably damped. A little bit like concrete, actually, thinking about it. But the point was, when we started looking at G1, and I was looking at the size of this loudspeaker, thinking,
It's going to be hard.
This is going to be really heavy.
Yeah.
And do you know what? I've moved loudspeakers around. In fact, my back tells me I've moved loudspeakers around for a living. And anything we can do to keep the weight down, you know. Oh, and I have to say this, but one of the reasons we can get away with a lightweight speaker is because we use these reaction cancelling bass drivers. Whereas an ordinary front-firing speaker, you know, you need mass to hold the speaker down. But if you've got reaction cancelling, you don't need the mass. So that leaves the door open to use light, stiff enclosures. And of course, the world of light, stiff materials, it's the world of aerospace, the world of Formula One, and they're all using composite sandwiches. So with that in mind, when I was designing G1, I mean, I've always been interested in materials anyway, so I knew that this was the sort of direction we were going to go in, but I didn't know how we were going to do it, because up to that point we had no experience of vacuum infusion, which is the process we use.
I saw a video about it.
Right.
It's pretty cool.
As I say, I'm interested in materials, in composites, and so I knew that this sort of thing was used in high-performance boat building. So I literally Googled vacuum infusion, yachts, South Africa, and bang.
Number one.
Yeah, really. A company called African Cats, if I remember rightly. And the freakiest thing was that they were literally 5 minutes from our factory, really just around the corner. And they were owned by a Dutch guy who lived somewhere around here in Holland. I contacted them first, and they said, "You better speak to our boss." So I picked up the phone to this guy in Holland, and he was so cool, so helpful. And when I described what we were doing, he was saying, "Do you know, in a funny way, it's sort of what we're doing in the world of high-performance catamarans." And so, you know, really pushing the material, pushing the performance, and
well, in a way, it's comparable.
Absolutely. So he said, "Look, I'd love to help you. I'd love to build the cabinets for you, but do you know what? We're actually up to here with work," which is great for him. And he said, "But I'll tell you what. I'll lend you my head of production and a couple of members of staff, and they can help you design the tools and teach you how to do vacuum infusion," which was just...
He told you how to do it.
Yeah, so, and they actually invited us into their factory where we saw all these incredible vessels being created. And he set aside a little corner of the factory where they built the moulds and made the first G1 cabinets for us using this vacuum infusion process. Just an incredibly generous thing to do. And then, actually, having shown us how to do it, we then took all the tools back to our factory, and he let them, these two guys, come with the tools to carry it. Anyway, so that's the little story there. An incredibly helpful and generous Dutchman whose name, sadly, is lost in the midst of time. And I'd like to shake his hand now because it was a tremendous leg up. Anyway, so that was how we got into vacuum-infused composites. And, we haven't looked back. It's great. It's a great process. You know, you really do make high performance.
Your loudspeakers, and there's one thing, because I think they're almost finished over there. Your loudspeakers are shaped different than others. I mean, most are straight lines, units in them, that's it.
Yeah.
And they're bigger because you need bass. But yours are all curvy and organic.
They're certainly organic, but as I always use the line form following function. Sound doesn't like sharp corners. Sound sees sharp corners, and if you make a smooth shape, then the sound will emanate from the loudspeaker and flow smoothly around the cabinet without bouncing off the sharp corner. So it produces a cleaner sound field. It's as simple as that. So that's our reason for using the curved shape on the sides. But the other big curve, of course, in our Giya loudspeaker is this curve at the top, the curl, top.
curl,
And that is this unique design feature, the combination of an exponential absorber with the bass reflex of the bass chamber. That absorber prevents the usual top to bottom resonances that you experience on any ordinary square box. Actually, do you know, even our early oval speakers, which were far from square, but actually they were still technically an ordinary box acoustically, and if you measured them appropriately, you could see that the sound still bounced from top to bottom. Putting the exponential absorber completely eliminates that issue, and you can hear it. It tightens up the old bottom end, no end.
I thank you very much for your time.
Pleasure.
And great demo. We'll post both, of course. You can see the demo and our interview separately. Laurence Dickie, Vivid Audio.
Thank you very much.